In this video, we are going to determine whether the following series converges or diverges. So here we have the sum from n equals 1 to infinity of 1 over n times 7 to the n. So for this, we're not quite sure what test to use. We don't see a minus 1 to the n anywhere, so we're probably not going to want to use an alternating series test. But we do have 1 over a denominator that has some things in terms of n, so maybe we're going to want to use the ratio test. So let's recall what the ratio test tells us. So suppose that we have some series summing up an. We want to define L to be the limit as n approaches infinity of the absolute value a sub n plus 1 over an. So we'll define L as that. Then to determine whether the series converges or diverges, it depends on L and the following three conditions. So if L is less than 1, then the series is absolutely convergent, so it converges. 2 is if L is greater than 1, then that tells us that the series diverges. And then lastly, the only other option is L equals 1. And in that case, we're not entirely sure what can happen. Then the series may diverge or be conditionally convergent or be absolutely convergent. So we're not sure what happens in that case. But let's try to apply the ratio test now. So first, an in our case is 1 over n times 7 to the n. An plus 1 is going to be 1 over n plus 1 times 7 to the n plus 1. Now, an plus 1 over an is going to be 1 over n plus 1 times 7 to the n plus 1, all over 1 over n times 7 to the n. Now, recall that if we have two fractions that we're dividing, so if a divided by b dividing by c over d, I can write that as a over b divided by c over d. That's the same as multiplying by the reciprocal, so that's the same as saying a over b times d over c. So this an plus 1 over an is going to be equal to 1 over n plus 1 times 7 to the n plus 1 times n times 7 to the n over 1. Now we want to define our L. So L is the limit as n approaches infinity of the absolute value of an plus 1 over an, which we just determined is n times 7 to the n, all over n plus 1 times 7 to the n plus 1. Now, we can simplify this a little bit because we know that we have a 7 to the n over 7 to the n plus 1. So that simplifies to just 1 over 7. So here I have an n in the numerator, and in the denominator I have n plus 1 times 7. Now, what happens here? As n approaches infinity, this n over n plus 1, well, they have n is raised to the same degree, so that essentially is going to be like 1. And so what I'm really left with here as n approaches infinity is going to be 1/7. Great. Now let's look at what our rules say. If L is less than 1, which 1 over 7 is less than 1, then the series is absolutely convergent, which means it converges. So here we're in this case. And so this tells us that the series converges. And that was by the ratio test. So if this video was helpful, please like and subscribe. And if there are problems you'd like to see solved, feel free to email them to ashmath1729@gmail.com.